All right. Hi, everybody. Welcome to Schulich Ignite 2022 Flare session. This is session 2. Today is going to be a good day. We're learning a little bit about objects and classes today. Also, if you have any technical errors from your code, don't be scared to ask on Discord in the Mondays general questions channel. And then just keep in mind that Zoom chat is for questions related to the session content or interactions during the session. If you don't have Discord, you can sign up, or no, if you do have Discord, you can sign up for a private group channel following these steps you see here. And so, okay, yeah, let's get right into it. So for this session, we'll be talking about objects, classes, and we'll start a little bit of our game. So it's going to be a fun one. So objects. In programming, you technically don't need objects. So objects are a construct that we've created as designers and programmers to make things easier to scale or easier to organize. There's a lot of benefits to objects and classes as well. So they make our code more organized, simple, and modular. So a quick analogy here. So if a variable is a box that holds values in it, then an object is an even bigger box that holds more boxes inside it. Even better, objects help you keep smaller objects or variables organized. So if you look on the right side here, we have an object at the top level. This object holds 3 variables, and those variables hold a value each. So the one on the left side of the tree holds the value 21. The one in the middle holds the string Casey, and the one on the right holds 3.14. So essentially in code, this object has 3 variables here, and this object itself is a variable. So objects group things together. Properties is what they're called. So for example, we've used objects so far in this class when we drew anything to the screen. So pygame.rect creates a rectangle object for us. Rect is the class, and when we assign rect1 the pygame.rect method or function, we get a rectangle in that rect1 variable. How can we tell so there's a question in the chat. How can we tell if something is an object or a variable? That's a great question. So there's ways to check in Python. You can check by using, by verifying its type, and I'll show you that a little bit later. I'll show you when I start the first exercise, I'll give you an example. But most things in Python are objects, actually. Lists are an object. This rectangle is an object. So it's good to know, but like objects kind of can take the many shapes and forms. So for example, a rectangle is an object and a rectangle has properties. So what we've used so far has been its X and Y coordinates, or its top left coordinates there, and then the width of the rectangle and its height. So on the right side here, we've done this before. We've created rectangles. And so you can modify their X, Y, their width, and their height. And just to keep it simple here, rect1 and rect2 are different objects. Or they're both like rectangle class, but they're different objects. Devin?
Yeah, so when you say the coordinates of the rectangle, does that mean like where the coordinates of one of the corners will be on the rectangle?
Yeah. So the like the x.x is the top left, and is the x value of the top corner, and then the y value. So x and y are the top left coordinates for that rectangle.
Okay, so like the values at the top left corner of the triangle. Thank you.
Or, yeah, the rectangle.
All right, thank you.
No worries. I hope that makes sense. We'll get in a little deeper here. So objects are nice because they hold values for us and they kind of organize stuff. Oh, another question. Okay, so to be clear, both of these objects are different objects of the same type. Yeah, here, one second, go back. So imagine if you created like a variable called number, and then you gave it 1, that would be an object of type integer or number. And then if you created like another number 2 and then assigned it some other value, that would be its own. Yeah, an object, like you can assign a variable an object basically. It's a type. And you can define these types yourself using class, like using a class. And we'll get a little bit deeper into that as we go. So just to keep it straight, a variable is something that you name yourself and then you can assign value to. An object is something that you can assign to a variable, just like you can assign a number, a Boolean, words, lists. So yeah, we'll keep going there. So we talked about the dot operator last time briefly, and we've used it a couple times. One second here. In Python, if I were to do rect1 equals rect2, would it copy the values of the memory location of rect2 to a new object rect1, or does it just make rect1 point to the same memory location? I'm actually not totally sure about that. I know that some programming languages do pass by reference or do a point to the same memory location, depending on how you assign it. So for instance, JavaScript does it that way. I'll have to double check when we do the first exercise so I can give you a proper definition there. Okay, so I'm just going to continue going here. So we've used the dot operator before, right? So we've used it to use methods associated with Pygame and to create the rectangle objects. So how it works is if we assign something, an object to a variable name, to access its properties in the object, you would state the variable like you see on the left, student1.name, to access its name property. And then in that name property is stored a value. And so, for example, like we have this stuff on the left here, student1.name.id.program, that gives us different values based on what we've put into there already. And we access those with the dot operator. Does that make sense to everybody? Before we jump into the exercise 1? Okay, I'm gonna keep going then. So before we jump out in the breakout rooms, we're gonna do an exercise here. So I'll just show you quickly how to get these folders or these files again. So if you go to this, the slides, and you click these files here, you can right click on the page, save page as. You could do leaves.py. Make sure you save with a .py extension. And then you could just save that. I'm using my pygame.first file or folder. So I'll just save it in there. Same thing with this one, save page as .py, save. And then I'll have those all up and running in that folder on VS Code. But anyways, so basically in these files, you'll find two files, or yeah, you're getting 2 files. So in one of those files, you'll find a leaves class. Don't worry too much about that. We'll go more into depth about that later. And then you'll find a main that's already laid out for you, and it'll show you a little bit about how to access that leaves and how to use it. There will be an example. But your goal is to add leaves to the tops of the tree trunks that have already been put into this file for you here. So here, let me just grab that. I have it open on this monitor. So for example, the tree trunks are drawn here using the rect method that returns a rectangle object. And then you would create your leaves like this, and then pick your coordinates, the size, all this stuff. Does this make sense? All right, so I think I'm ready to put everybody into a breakout room. Bod, can you help with that?
It should be open now.
Okay. Thank you.
No worries at all.
All right, everybody should be back. Okay, awesome. Here, I'm going to share my screen again. All right, so while you guys were gone, I just added some extra colors so that I could walk you through some putting some leaves on top of these trees here. So I'm just going to close that. I was just stealing some fall colors because the trees are pretty these days. So, all right. All right, okay. So I'm just going to quickly run this just to show you guys or y'all what you should expect when you first run this without writing any code. So we have there are leaves in the top left. We have some trees down and around that we need to add leaves to. So that's not too bad. So I'm going to just do this. I'm going to create multiple leaves here. All right. 3 for 3 trunks here. So let's just start with the first one. So we have a tree trunk 1, which is located at 200x, 300y. It's 20 width and 80 length. So, I mean, it's up to you guys or you all what you want to put here. So, for example, I want it on the tree trunk. So, and I kind of want it centered. So the trunk is at 200. So then we want to be, and its width is 20, and we have a size of 50. And so when we draw this down here, we fill in, like our leaves are, the size is being filled in for the width and the height here. So in this one, it was explained as, or it was defined as 100. So I would put my X at 100. And then this one at 100 more than or X at 100. Because then plus another 100 here from size would put it at 200. Actually, 50. We want to do it in the middle, actually. And then this would be, well, let's just see how that looks. Not quite, but it is a tree with leaves on it. So we do have that going for us. I'm just going to put the other leaves kind of relative to the trees right now. I'm also going to add new colors as well. So I'm going to leave that one as green. That was already defined for us. And here I'll do orange. And here I will do yellow. All right. Actually, I believe this would just be 180. I messed up again. It's all right. Okay. So, okay. So for leaves2.x, so our second tree trunk here is defined at 400x, 450y. So we can do a little bit before the y here. So and then somewhere around that x or that y. Actually, this was supposed to be 160, I believe. I'm just now it's coming back to me. Okay. Okay, yeah. And this should be 290. And then I'm going to just change this to 160 here, just for fun. And this one I will set to 570. And this one I will set to 270. And this one I will set to 80. I'm just also going to check chat here. Are classes and file names case sensitive? Yes. So, for example, if we did this as a lowercase l, and then I tried to run this, you would get an error here because leaves is not defined. So it is case sensitive. So you do have to do that. And then when you import things like up here, so we're importing from the leaves file, which is case sensitive, we're importing leaves. So for example, if I put capital leaves there, you see it squiggles, can't actually resolve that, which is a nice thing about Visual Studio. So when you run this, you would get this error, no module named leaves. Oh, reminder on time. All right, so here's a quick. And then we also, so what I forgot to do here was I forgot to actually draw the other 3 leaves sections here. So bless you.
That's me. Oh shit. I forgot to mute myself. My bad, guys.
It's okay. All right, so I'm just rendering these. All right, quickly. So there you see, there's some trees there. Forgot to change that to the proper color. I think I must have put the wrong value in for yellow maybe, but no worries. So basically, does that make sense? Oh yeah, also I was looking up before this where somebody had asked if you assign a variable in Python, does it make its new copy or is it just assigned to the same object? It does assign to the same object on assignment like that with a variable. All right. Okay, so let's move on to classes here. So the difference between an object versus a class is it can be a little confusing to start with because they can be kind of used interchangeably. But for example, a class is more like a blueprint or a recipe for building an object or making an object. And it has templates for what you would expect to find in your object. And then you can think of an object as like a physical thing that has properties unique to itself. So for example, you have a class snake, right? And a snake can have, for example, its name, its color, its species. But when you create a snake using and assign it to a variable, you can choose what you want to set that for. So when you create your snake1 object, for example, you could give it a name Buttercup. You could change its color to orange. You could change its species to a rattlesnake. And then you could do something similar with snake2, but change its name to Venom, give it a color green, and give it a species Python. So classes just give you a template for how your objects should be structured. Here's a simple example of a class. So again, with animals, we have a class dog, and that name, we typically do capital letters for class names like this, starts with a capital letter. It's nice to, when you see that in code as a programmer, if you go into a new piece of code, you would know that that is a class. If people are following the convention, it's just nice to do. You don't have to do that, but it makes your code easier to understand from other people. Down here in this class is a function that is weird looking, right? It has multiple underscores to start, init, multiple underscores after, and then it has self in it. So this is the function that is called when you do dog parentheses, like my object equals dog parentheses. So this is the function that gets called, is this init function. And then this self keyword is like a fancy way of just saying that I'm giving it this object. So like, for example, when you do dog parentheses, you're passing itself to that constructor here, this init function. And then you're assigning number of legs to 4 and sound to woof. So these are the properties down here, self dot. You have to remember that when you're setting properties of your objects. Why does init have 2 underscores on either side? It's to denote that this is a constructor. This is what will be called when you create an object of class dog. So you have to actually type the init like this to have it function that way. So just a little bit more. init is a function inside the class. It's the constructor that makes the class blueprint into an object, the thing. So you can think of it like a factory. So class is like some schematics, some blueprints. When you call the init function, you build that using in Python, and then you deliver that object. So you create that object when you call that init, or when you use the constructor. All right, so here's an example. The constructor takes in any numbers of arguments and creates an object, which is also called an instance of the class. Make sure you always put the self argument first, and we'll see why soon. But so here's another example of a init. All right, member variables, also known as properties. So you can kind of use them interchangeably, but they're properties that belong to that class. So you define those in the init function here. So this class person has a name, an age, and a gender attached to it, right? And then you can also see that this init function is being passed arguments. It's being passed a name, an age, and a gender. So what this will do, and we'll see in a slide here, is that this will, like, you can create like an object of person and then pass it these arguments to assign it to the person class, or the person object. The arguments to the constructor are often named the same as the member variables, but they're different things. So note how it says self dot. You wouldn't do name equals self dot name. You would get an error. You want to assign to the object self dot name. All right, so let's start here. Quick question of the day. What is wrong with this code? Is that everybody, I think? All right, I'll just end the poll there. All right, so we had 18% of people say self should be the first argument, 29 saying incorrect indentation for line 3 to 5, and then 53% said A and B. So the answer is that A and B are both incorrect. Self comes first in the init constructor, and that indentation is wrong. You will get an error there. Does that make sense? All right, let's move on. What is self? So self is how a Python object sets and uses its own properties. So here's an example of that. We're assigning self.name, the person name, self.age, the person age, self.gender, the person gender. I hope that's getting through. A selfish analogy. Python uses self like we use the word my in English. So for example, you can think of my name, self.name is name. My name is Jimmy. Self.age equals age. My age is 17. Self.gender, my gender is male. So like in English, when talking about someone else's age, you don't say my age, you say Jimmy's age. So here's an example of an object being created using that init function. What happens if you don't have the self parameter? Okay, let's go back. So if you don't have self, you would just be creating a local variable. Well, first, you would definitely generate an error in this case if you remove the self dot, because Well, you wouldn't actually, you might not receive an error there. You would just be reassigning the value to as itself, but you wouldn't actually attach it to the class. So then when you go here and try to print Jimmy's age, you wouldn't get anything. It would have no age attached to that object. So self kind of just binds this dot name to the person class, to the person object when you create it. And so, for example, here we have a variable Jimmy and we assign it via the person constructor. So that's what that init turns into when you call person parentheses and pass the arguments there. So we can pass it a name, Jimmy, 17, and male. And then we've created a person object called Jimmy, right? And then we can print that age, we can access it, or we can change it via the .age equals 80. So the self argument is not included when creating our object Jimmy. Only the name, age, and gender is included. That's all handled within Python. So that self there, you don't actually have to put that in with the actual constructor when you use it. So we're gonna build our first class. So let's start building a snake class. So everybody, if you want to follow along, in Visual Studio, make a class, a new file called snake.py, and write the name of the class in that file. Remember that class names use the Pascal case naming convention. So that just means you capitalize each word following. So if you had like a class called snake wings, I don't know, you would capitalize every following word as well. Next, we will create the constructor using this underscore init underscore, pass it self first, then my name, and then we can assign self.name equals my name. And just remember that self.name is necessary and it's a member variable, or it's called a property. So when you invoke or when you create a variable mySnake and assign it a snake object, you can give it its name here, Buttercup, and just know that the self argument is automatically included, so you don't have to worry about that. Remember when the class is created, the init function is called. So that's what's happening here. And that S will be printed because we've defined it in the init. It's like a function, like any other function. It'll run as well. So as you can see in this example, we can create a new variable called snake name and assign it mysnake.name. And then when we print that snake name, it would print Buttercup, just like we've assigned in the class or in the object when we instantiated it or created it. Does this make sense? Does anybody, maybe I'll walk through it really quickly. Quick, here, I'll call it snake.py class snake. Define init self name. Self dot name is equal name. Print my snake is equal to snake. I'm gonna give it a new name. I'm gonna name it Jeff because that's a great name. Alfred, if I'm pronouncing that properly, you can head to you can attend the Discord after to learn Alfred. Okay, you can attend the Discord or watch the previous lectures if you are not following right now. But stay with this one too as well. You might as well. And then I'll print my snake dot name. Yeah, so use whatever if you already have a code editor that isn't the one that I'm using and you like it, go ahead. You can use whatever you want for this. So as you can see, I created a snake, Jeff, assigned it to my snake, and then printed out the my snake name. But when I created my snake, Jeff, it also ran this code in the init function here. And it printed SSS or hiss or whatever, as well as the name when I printed it down here. So this is just a quick example. Oh, whoops. Okay. Oh, wait. All right. So here's another question. What is the correct output here? We have a class person. We've not defined an init, a constructor, passed itself first, self.name equals George, print self.name, and then we've created a new object by calling that constructor. We'll give it another like 30 seconds here. All right. I'll give like 5 more seconds here. Okay, I'm gonna end that. All right. So the best way to, here we go. Sorry. Is to just do a quick little demonstration here. So if we create this class now, human, and then give it an init. And then in that init, we just print self, or we say self.name equals George, and then print what do you, and then so that's our class there. But then we also assign it like this. So save that, and then, oh, it's person, not human. And then when you run that, one sec, sorry. You get George. So the correct answer is George there. All right, let's go back. So a cool thing about objects and what makes them so powerful, what happens if the class name is identical to the object being initialized? Do you mean by? I will let you guys, we'll talk about that a little later. I'm going to keep going with the lecture. All right. Somebody else will answer your questions in the chat. So something really powerful about objects is that they can hold other objects. So that can lead to some pretty interesting behaviors in your program and structures. So a big box, think about it like that, can have another big box inside it, which can have other boxes. Kind of like, have you guys ever heard of those Russian nesting dolls? Kind of like that. You can have as many things as you want basically in an object, but it can be kind of confusing if you create like a super object that holds a lot of things. You kind of have to use it based on your proper use scenario. So here's an example. So a spacecraft, the Mars mission spacecraft has a sky crane, and that sky crane has the Perseverance rover, for example. Or if you want to think about it in like a simpler, if you have a person class, that person might own a dog, and that dog might have a name, and there's other things there, right? So like you can have objects that have objects. And since objects are just variables, there's no new syntax, right? So you can give the snake a rect property, and that might have an X property. So for example, if we were drawing snakes to the screen, this is what you could kind of expect here. You could create a rect using pygame.rect. And that's what we'll be, maybe a little bit of a spoiler, we'll be doing that a little bit later in this lecture here. And then you can also access it like you access any object. So you can define your snake variable, access its rect property, and access that rect's x property. Does that make sense? All right, and then we'll also get into imports, which is what we were doing with that leaves file that we had looked at earlier. So this is kind of nice because it lets us organize our code, and you can give access to code from another file. So for example, we just made that snake.py. We could import that from another file and use that snake class. So it's kind of nice to stay organized and have different files for different classes and keep similar things together. It's up to you how you organize your code, but it is recommended that you try to organize your code using imports. So here's an example. So from another module, that would be the file name. You can import a class, some class. This imports the sum class from the file, another underscore module.py. So here's some more naming conventions here. Capital letters for the start of every word in some class indicates it is a class. And then we do kebab case here for modules. And classes are typically placed in their own file. Okay, here's how we can use imports too. We don't have to, we can import it this way as well. So before we were doing from another module, import some class, we could just import the entire file, basically, if we have a lot of functions in there or classes that we want to use, right? So, but when you do it this way, import snake, you have to call the module name first, then .snake to use that constructor. And make sure you write your imports at the top of the file. Python also has a lot of built-in modules that will help you out. For example, OS, there's also a math module, and something that we may or may not be using, or you may or may not be using in your game dev journey would be maybe random. You can use that to generate random numbers, and it's really helpful. And also, what we are actually using for sure is Pygame. Pygame itself is a module, and you can import it. And we have been doing that, working on these examples. So yeah, and then like I said earlier, all right, we're back. So I think where I was at again was just explaining further the imports. So like I had said earlier, you can import specific parts from your Python modules, your other Python files, your .pys. So from that snake.py we made, I could import the snake class specifically. And then it can be a class or a function. So from snake, import snake. Here, let me put this in proper slideshow. There we go. All right, so let's get started on our game. So this leads us into kind of a big exercise here. So if we're going to create a platformer, we're going to need to know how to create platforms, right? So we're going to make a platform class ourselves and draw it. So that's our first goal. You might see on the slide here, they're moving back and forth or coming in from the left and moving across the screen. If you can do that, that's a bonus. And if you can make it wrap around, that's an even better bonus to create an infinite loop. Can you import other things in classes? You can import functions as well. So I think we're ready for a breakout room. If you all want to get started.
I need to reassign keys to the room, so give me one moment to do that.
Okay, no worries. Here, I'll show you guys a little bit about some of this stuff. So I'm going to create a new file, call it platform.py. And in it, I'm going to create a class called platform. here's just an example of how I would maybe handle this, you know, create a platform, give it a rep potentially. All right, breakout rooms are starting. All right, good luck, everyone.
Whoever is here and is a mentee, I think you guys should be assigned now. So if you guys want to head out to your breakout rooms.
Can you help me set a timer for like 5 minutes and then I can go to my breakout room?
Yeah,
Uh,
here, I'll set a timer.
Oh, perfect. Thank you.
Is this by? I think this is the end of the slides. If I'm not wrong.
It is, yeah. I think all I have left here to do is do like a live demo of coding the platforms and then making them wrap maybe.
Can maybe give them 10 minutes for this one in that case, since we're a little bit early today.
Okay, yeah, for sure. How do I actually give them a timer for their breakout rooms?
I can actually, so the way that you do it is that you go on breakout rooms and then you should find some options on the. Oh, actually, I think you have to set it before you send them out to the breakout rooms.
Okay.
So now it's too late, but if you did it before sending them out to the breakout rooms, there should
Yeah.
be like a bottom left options and you can click on it and then there's like that timer that you can set up.
Okay, that's good to know for next time.
Yeah, and just make sure to kind of maybe bring them back at like 6, 5 or 7, 5 maybe.
Okay, yeah.
Oh, Nisa assigned to the wrong one. Sorry guys. Okay. Nisa, which person is your mentor? Jade? Nice. Okay, let me do that right now. Jade. And which one were you assigned to by? Okay, there we go. Move to Jade. Sorry about that. Now you should be good to go. Hey Navia, were you assigned to your right mentor or? Oh, you were not, sorry. So you're also with Jade. Cool. You should be good to go now. Okay, John, I think I'm gonna head out.
Yeah.
I think Fanny's got it from here. And then just, yeah, today should be fine.
Okay, sounds good.
Cool.
Take-
I'll see you around. Thanks
Sounds
for
good.
making it today.
Yeah, no worries. Take care.
Hopefully this doesn't shut it down for everybody.
Yeah, hopefully not. We'll see.
We'll see. Okay, let's see.
Hello.
Hello, can you enable screen sharing?
Um, all participants, maybe? Is that okay?
Yeah, that should be okay.
All right. Is that good? Does that work now?
Let's find, oh yeah, it works.
Okay, awesome.
Is there a way for me to enable screen sharing for all? I
I
forgot it's
think-
under security.
I think for
Done?
all,
Okay.
I'm here. I have it. It should be all participants can share right now. Is it not working?
Somebody asked on Discord, so let me check with them.
All right. I hope everybody had some fun there and was able to get maybe some platforms drawn on the screen and maybe a class and a module set up. But I'll kind of walk through my solution and then we'll work through moving the platforms together is what I was thinking. So let's start here. Let me know too if the font size is big enough. I'm just gonna assume it's good. Yeah, okay, it's good. I'm gonna maybe make this a little bit bigger. So I'll just show you. Here's my Python 3.mainpy or main.py. So here are my platforms. I've just kind of put them in some random kind of staggered fashion here. So there's that. I've imported some modules at the top here. Before y'all have left, let me just see some of these. Do you have Pygame installed? Oh, okay. I'll leave that to the mentors to help you with. So I personally like using random a lot when I am coding in Pygame. It just allows for some extra fun and stuff like that. So I've imported the random module and from the platform class module that I've created myself here with a class platform in it that takes an erect and a color. I've imported that class.
You're joking.
Why do I always overcomplicate it, bro?
And then, so in my setup section here, I've created a class or a function that creates a random color from 0 to 255. And then I've created a list of platforms and I've created, what is it? From 0 to 5, non-inclusive. So 5 platforms there. I've created an X based on the index of the number I've created. And then I assign that to this rectangle that I give to my platform right here. And a color as well that it generates. So then in my while true loop here, skipping over the events and all that, I go to my draw section. And for all of the platforms in my platforms array, I use pygame.draw.rect to draw it to the screen, the platform color, and the platform rectangle. When do we know? So there's a question. It's up to you. When do we know when to put functions or classes in separate files versus in the main file? You should probably always put your classes in a separate file. Functions, it kind of depends on your preference. If it's related to your platform class, maybe you should put it in this file with it. So like, I don't know. I'll show you in a second here. But as for right now, it's kind of up to you. See, I put it in here because it was just right there. It's easy for me to put right there, but it could easily go in its own file as well. So we're gonna get started here, actually moving the platform. So manipulating the objects and the data in our game should go in this update section here before the draw section. And that's because you want to draw them after they've been updated. So what I'm going to do is I'm going to get all of my platforms and I'm going to make them move to the left of the screen. So for every platform in my platforms array or list that I made up here, I'm going to grab that. I'm going to do p.x is equal to p.x minus 1. And so that should actually move it leftwards, if I'm not mistaken. One sec. Platform object does not have no attribute X, right? And that's a good thing to remember because I had passed it the rect object, not the X itself. So I need to actually use the p.rect to actually access that. And that's kind of like what we talked about earlier in the lecture, where an object can have an object. In this case, our platforms have rectangles. So there you go. There's our objects slowly moving across the screen. They do not wrap, however, which is something that I will also quickly implement here as well. So we can add a check here in this for loop. If our p.rect.x
Is greater than screen.
is less than p.rect.width, or no, sorry, the negative. So kind of what I'm thinking here, the way I'm thinking about this is we have our x value in the top left corner, or our coordinate of our rectangle in the top left corner. So that left part, the width, or the way the rectangle is drawn, is the width gets added to that x point, and that's what creates like the rectangle as you see it. So what we're gonna do is when that the end of the width actually goes off the screen, that's when we'll flip it back to the other side of the screen, and then it'll come across again. So we want to look at when the x value is less than or equal to the negative of the width. Or how you could think about it is if you minus the p.rect.width is less than or equal to 0. And then we'll set p.rect.x is equal to the screen width, because then that's the basically the origin point, or the leftmost value of that rectangle. If we put that at the screen width, that'll put it right on the other side of the right side of the screen there. I'm pretty sure that's correct. Is it better to have the platforms wrap around or make new platforms as time goes on? So that's a great question. Okay, this is not working exactly how I had envisioned it. 1 second here. I did some math wrong here. But basically, it depends on what you're trying to do. For example, I was working through this lecture a little bit like on the weekend, and I wanted an effect to happen where when my platforms were wrapping around the screen, as soon as a little piece of the rectangle was off the screen, it would come on the other side of the screen. So in that case, it made sense to draw new rectangles as that happened. But in this case, we can just reuse the same rectangles. So let me just, sorry. So if the x value is less than or equal to, 1 second, I'm just gonna, I always get a little nervous when this stuff happens because coding live can be kind of challenging. So just let me double check here. It should be plus. Let's think about that. So our x value, when it goes off the screen, is a negative value, right? And our width value is always a positive value. Yeah, so you are correct. Thanks, Alfred. Should work now. Maybe I should turn the speed up a little bit, but as you see, when it reaches the end of the screen there, it should wrap around. Thank you, Alfred. So does that make sense to everybody, or is this really confusing? Are there any questions at all? What does my array contain again? Okay, yeah, it gets a little messy in here a little bit. So I've created a list of platforms basically, and in my platform objects, I have the rectangle, like a pie game rectangle, and then a color associated with it. And then so in this for loop that I set up before the loop begins, I create my positioning, and then I pass it a random color that I used from this random color function. Are there any other questions? Was anybody able to get some platforms on the screen today? Anything like that? All right. So with all that, that is actually the end of the content on this slide. So that is the end of, I made some platforms go, that's really good. Yeah, that's awesome. You should try seeing if you can get them to wrap around from the backside as well, like I did. And then if you really want to challenge, maybe you could even have the green side of the, or like the other side of the rectangle come off before it completely goes off screen so that you see it transitioning more fluidly. Made platforms that bounce off the walls. That's really awesome. Importing still causes an error message for me. Dylan, I've actually maybe ran into this. Did you call your platform class module platform.py all lowercase? Okay, so that's an actual module in Python already, and I ran into this a couple days ago as well. So you should change the name of your Python file, your .py file, to something else, and then import that instead. So yeah, here I'll show you. I also ran into it again today because I forgot, but see, I changed my name to platform underscore class.py, and then that's where I'm importing from up here because there is a platform module. Yeah, no worries. So yeah, with that then, I think if there's no more questions, yeah, of course, then we're done with session 2 here, and we'll continue next Monday. So I hope everybody had I wasn't here for the other, so I was trying to make it out of the turtle module. I'm not even sure what you mean by that. Is there a slide for what you covered before? There are slides. If you go to schulichignite.com and then go to the Flare section, you'll find some slides there. Oh, you didn't know Pygame exists. Oh, okay. Turtle is its own thing, right? Okay, yeah. Yeah, you can find Pygame or the other modules. There's also the YouTube channel where you can see the past lectures as well. Is there a link here? Posted that. You could also go to the YouTube channel too. I'm not going to click that because, yeah. All right, I'm going to stop recording.